Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading and sometimes singing. Continue with The Cat in the Box, story number 21, Weighing the Earth. Isn't it amazing that a person can actually can determine the mass of the earth that we live on. It's quite incredible. Weighing the earth. The experiment usually described as weighing the earth was first carried out at the end of 1790s and reported to the Royal Society in 1798. But in fact, this experiment was the first determination of the strength of the force of gravity, which turns out to be the weakest of the forces of nature. The experiment was devised by John Michell, who had been a Cambridge professor but gave up his post in 1764 to become a parish priest, although he continued to study science in his spare time. Mitchell was the first person to come up with the idea of black holes in 1783. But by then, it was well known that the speed of light is finite, and Newton's law of gravity showed that the more massive an object is, the faster you have to move to escape from it. Mitchell calculated that an object with the same density as the Sun, but 500 times the diameter of the Sun, would be so massive that this escape velocity would exceed the speed of light. He wrote that we could have no information from sight of such an object. It would be, in modern language, a black hole. He was also interested in more down-to-earth studies of gravity, as well as thinking up an experiment to measure the strength of gravity. Mitchell got as far as building most of the apparatus needed for the experiment, but he died in 1793 before the experiment could be carried out. All his scientific equipment was left to his old Cambridge College, Queens, but nobody there was up to the task of doing the experiment. So the equipment was passed on to Henry Cavendish, one of the most careful and successful experimenters of his time. Cavendish was a wealthy aristocrat and recluse who had the money and inclination to devote all his time to the study of science. So the measurement of the strength of gravity became known as the Cavendish experiment, even though it was devised by Mitchell. The experiment is very easy to understand, but painstakingly difficult to carry out. It was constructed in an outbuilding at Cavendish House on Clapham Common, then still a village on the outskirts of London. The centerpiece of his experiment was a strong light rod, 6 feet or 1.8 meter long, and made of wood with a small lead ball on each end. Each of the small balls weighed 1.61 pounds. or 730 grams. The rod was suspended by a wire from its exact center so that it was in balance. 2 much heavier lead balls, each weighing 348 pounds or 157.85 kilograms, were mounted on swivels so that they could be swung into position at a very precisely measured distance, 9 inches or 22.86 centimeters from the small balls, each of which had already been weighed very accurately. All of this experimental equipment was placed inside a wooden case so that no air currents could disturb it. Because of the gravitational attraction between the large balls and the small balls, the horizontal bar would try to twist until it was stopped by the torsion of the wire. By carrying out a long series of experiments, some with no heavy weights and the horizontal bar twisting to and fro like a horizontal pendulum, Cavendish was actually able to measure the force of attraction between each of the small lead balls and a 350 pounds, 158.76 kilogram weight. This force is about the same as the weight of a single grain of sand. But he also knew the strength of the force of gravity acting between each of the small balls and the earth itself. This is just the weight of each ball. So, from the ratio of these two forces, he could work out the mass of the earth. It is even more impressive that Cavendish completed these experiments not long before his 67th birthday. In fact, Cavendish did not give a figure for the mass of the earth, but quoted a number for its density, which is the mass divided by the volume. On June 21st, 1798, he reported to the Royal Society the combined results of a series of 8 experiments carried out in August and September 1797, plus 9 more carried out in April and May 1798. The figure he reported was 5.48 times the density of water, but he had actually made a slight arithmetical error, and the true density based on his measurements is 5.45 times the density of water. This is very close to the best modern value, which is 5.52 times the density of water. Cavendish was off by just over 1%. And although Cavendish did not do the further calculation himself, such experiments can be used to work out the so-called gravitational constant, G, which is a measure of the strength of gravity. For the vocabulary section, there are not too many today in this story. Detrimental, determination. Determine, I'm determined to do something. My determination. The common mistake is determined, which is not the case. We have to say determine. Strength. Strength with the TH sound at the end. Strength. Apparatus. Apparatus, or you choose. I think apparatus would be preferred. It's easier to say apparatus. Wealthy aristocrat. Wealthy, rich, right? Aristocrat. Recluse. Inclination. The verb is incline. Inclination. Swerve. If we say it fast. Swerve. Swing. Swung. Past participle. is an irregular verb. So swing, swung, swung. Okay, thank you for your precious time. And I will see you in the next story. Bye for now.